Hey,
Hello.
how's it going?
Good. What am I wearing, you ask? Well, this is
Well, what are you
this is
wearing?
what I'm wearing. Hello.
Hey.
How's it going? Good.
Oh shit!
What am
I gotta
I what am
turn
I
on
wearing,
this.
you ask?
Hold on.
Whoa.
Hold on.
What are you wearing? What is happening?
Wait a minute. Yeah, that was. I turned off. Sound off for that one. Tammy, can you hear me?
Yep.
Oh, okay. Um, hey, how do you like that shirt? How does it fit?
Well, this is actually the defective one. I was rushing around trying to find the good one, and I don't know where it went. But
Oh man,
it's probably in a pile of laundry somewhere. But yeah, like it. It's awesome.
cool.
It's not defective enough where anyone's gonna notice. So.
Oh really? My wife got so mad at me over the
Cheeky.
Space Time store because I got so obsessed with getting everything right, but some of them were really shitty, and so
I believe it.
it had to be fixed.
Like I said in the email, if you hadn't mentioned it, I would have just been like, "Oh, this is what it looks like." It wasn't that bad.
But some people were sending me pictures of their shirt, and they looked like a nightmare. So,
Yeah,
like,
I kind of like
but
that.
yeah,
I got like two good shirts. So
you got so you got the good ish. Hold on, I'm gonna sort Matt and Graham out really quickly. Uh,
yeah, am I right in not seeing anyone else here? Is that?
yeah, they're still coming online.
I just thought maybe you'd have a very intimate one-on-one voice video chat,
Yeah, it's just gonna be me and you.
just talk about
Uh,
clients that we don't know.
let's see. Yeah, here we go. There we go. Oh, Matt, are you there? Matt, if you're trying to say things, we can't hear you. We can't hear you.
Looks like he just has a fake video up, like in a movie when you try to trick people and you replace the surveillance footage with like a little loop of nothing.
He's just printed out a picture of
Yeah,
himself and he's moved it to
he's
his
not answering
wall.
any questions this call.
He's sign languaging us that he's gonna fix it and it's gonna be a minute.
2 minutes. Okay. Oh. Oh.
Oh, here we go. Okay. Oh my God, we got people here in the chat. What's up? Oh man, hello from Prague. Oh, I messed up and I sent an email out to people who are. That's weird. I wonder. Well, I don't know what happened. Whatever. Hello from
Wait,
Prague.
technical problems with our call? That's never happened.
No technical problems have ever happened. Uh, hello, no, hello Prague. People from Prague, Argentina, Minneapolis,
Whoa, that's really exotic.
Boston. I know, right? Minneapolis. Hi everybody. Everybody, start prepping your questions while we wait for Matt to get his sound sorted out. Where's Graham? I think Graham's in the wrong place.
It's on a solo video call.
He's in the wrong YouTube channel. Hello? Matt?
All right, can you hear me now?
Yes.
Oh, wow.
Here you
I
are.
didn't actually think that would work.
What did you have to hack together there?
Mike.
Right.
Yeah. Ingenious hack.
An ingenious hack. Headphones with a mic.
It's a life hack. And a beer.
Graham seems to be still in the wrong Hangout. I literally sent you guys. Oh, there he is. Good, there he is. Hey, Graham.
Hey, Graham.
Matt's drinking beer over there. Beer?
Yeah.
Getting good and sauced up.
Are you always drunk on these calls?
I'm sorry?
Are you always drunk for these calls?
I mean, I get drunk over the course of the call. Yeah, I don't always start drunk. Wasn't that the theme? I thought that's what we were doing here. Haven't you guys been doing that?
Yeah, we've all been doing drugs and imbibing alcohol throughout the entire call.
I'm wasted right now.
Are you at home, Tammy?
Yep, not in the office today.
Nice.
Nice.
Chilling.
Very nice. They let you out.
Or did you have
good behavior.
I'm chilling wearing this shirt.
Oh, that's a pretty sweet shirt. That's a fantastic design.
I mean, it's
we get
effective, but you know, they sent a new one eventually. So
evidently, Matt, the shirts that I thought really were terrible weren't all that terrible, and Tammy couldn't tell the difference.
Oh, okay. Do we get a tour of your apartment, Tammy, or is that like the one?
You should have given me some notice. I do not want you to see what it looks like now. That's why. That's why I'm just sitting. I can't get up and walk around the laptop. I just have to stay in this spot.
Yeah, that's right. I've framed myself carefully.
There's a dog hanging out right there.
Oh,
little doggy.
That's the most I can show you.
What's your dog's name?
.com.
.com.
Yeah, I don't know if, the show 30 Rock. One of the characters was named .com. So people are always like, "Oh, you like websites?" I'm like, "Well, I mean, we all like websites, but it's actually a character."
Okay.
So it's DOCOM.
Okay.
All right. So we've got people in the chat from Prague, Argentina, Minneapolis, Boston, Scotland.
Great.
Where else? Someone who Pat Gilmore just got back from Mexico.
We're so international.
Austria? Is AUS Austria or Australia?
That's Australia.
Oh, we got some Australia, New Zealand. Wow, Slovakia. Welcome from Slovakia, Tomas. Bratislava. Brian Van Grunsven is drinking a beer with you, Matt, there in Minneapolis.
Cheers.
There's to you, Brian.
We should do a global space-time tour one of these days. I want to go to all these places.
I thought you were going to say we should drink with all of the audience, but we can.
Yeah, I was just thinking that too. Like, we should have a beer hangout.
The advantage of this is no one can actually tell what's in it, so I don't have to justify anything.
What's in it, Graham?
Even though I'm not in the US, I can take the fifth, right?
Oh, wow. Leonard is from South Africa. Wow. Incredibly global.
Love that.
Kind of mind-blowing.
Not enough Americans.
Patrick's from Cali. Patrick used to be in Cali. And the Huntress is currently from Boring, California. Anything but boring.
California is not boring.
I mean, there's a couple of towns, but for the most part, it's pretty cool. All right.
It's crazy that people like science all over the world. It's amazing that people don't just do science in the United States.
Yeah, when you look on the map from the US, is it just the US and water? That's what I imagine.
That's what they teach us in school. Yeah. But when you grow up, you find out that there's more.
That's the way it should be.
It's weird. Yeah, it's weird for me currently being in a country that doesn't exist. Like, that's really awkward.
Well, it's like
right?
in the
How does it
old-timey
feel?
maps, it would say like, "Here be monsters."
Yeah.
Yeah.
That's
Australia is kind of true.
All right. Welcome everybody. Thanks for joining us for this February hangout. No, it's March. This is the February and the March hangout because I screwed up and didn't schedule one in February. I'm very sorry. Thanks for hopping on from all over the world and at all different kinds of times. I don't want to think about what some of these time zones mean for you guys in regards to how late it is or early. But so thanks for joining us. Matt, do you have any kind words for the audience?
Thank you very, very, very much for joining us. I mean, I missed you all. It's now, the year's getting on. We need to do this every damn month.
Yes, sir.
Because I can't see you through the camera, but you can see me. It's a one-way camera, unfortunately. So I really appreciate this opportunity.
Oh, the YouTube video. I thought you meant here. I'm like, why? Well, that doesn't make any sense.
No. I'm talking about, this was like, it was an obscure, more obscure.
What a weird computer.
No, it's true. Like YouTube is this very, even though there's the comment section, it can feel like this very one-way medium. A lonely place.
So what shall we talk about today? Sciencey. We've talked about the globe, but I think we're more into things beyond the globe. Shall we look at some questions?
Yes, there's a couple of questions that have started to filter in, but not many. So let's see what we can get going on in the chat here. The Huntress says, "Is anyone else super anxious for the image of Sagittarius A? The wait is killing me. Plus the possibility that we are going to see something unexpected." That's Sag A is Sagittarius A.
So Sagittarius A star is the supermassive black hole in the center of the Milky Way galaxy, our galaxy, 28,000 light years away, and it. So the Huntress is referring to the Event Horizon Telescope, which is an array of radio telescopes spread across the globe that are using interferometry to essentially image the down to the scale of the event horizon of that black hole, something that's never been done before. And so the answer is yes. I can't wait. I'm so curious. I hope it's not what we expect it to be.
How soon is that supposed to be released or available?
So maybe the Huntress has been following this better than I have. I know they released the last one I saw was something like a few times the Schwarzschild radius, so it wasn't quite down to the event horizon yet, but I haven't seen an updated one. But I suspect soon. I suspect this year. Maybe it's very soon. I would have to Google that.
Where are the Event Horizon array locations in the United States? Is there one in California? No.
Good question. Let me Google that for you, Eric.
I'm actually already on it.
Right.
It looks like there is one in Cali. We are planning some kind of special episodes of Space Time where we're actually going to get to travel, and so we're looking for interesting places to go. Where great science is happening, in the U.S. So if anybody has any requests of things that places they would like to see Matt go, shoot me an email and let me know.
Make it somewhere really, I don't know, with beaches. No, somewhere.
Hell.
Okay. Scrolling back up. Don't want to miss the questions that were posted at the top. Pat Gilmore says, assuming the second law, which was recently proven to be a probability, not a law, The universe started with nearly infinite structure. Does that seem surreptitious?
I would need Pat to post a link to this, whatever they're referring to, because I'm not sure what that is.
Pat, you hear that? Give us some more information. Scrolling down. Scrolling down. Oh, Matt, how was Richard Branson's Island?
Richard Branson's Island was exactly what you'd expect from a billionaire's private island. It was very nice.
Why were you there?
Tammy, you keep giving away that you aren't watching all recent episodes.
Well, I don't go to the very end when it's like question and answer stuff. I'm like, I'm done. And then
Yeah,
I put my name at the end, and I'm like, there I am.
Yeah. All right. You have homework. So I went there. I went there. When was it? A couple of months ago. Strange circumstances, as I said. Essentially, a friend of a friend who has way, way, way too much money decided that firstly he was going to take over the island for his like startup founder VC crowd and bring all his rich buddies down there, but he wanted an astronomer, and because you can, believe it or not, be surrounded by too many VCs and billionaires and things like that. And so I was that astronomer. I went down with my girlfriend and stayed a week, learned to kite surf, hung out with Branson and all these other tech kids, and it was insanely luxurious. There were like 100 staff for 30 maximum guests, I think, and so yeah, infinity pools everywhere. Lemurs. There are the most. I think by far the cutest animal I've ever encountered is the lemur. There are pink flamingos,
luxurious, and
giant tortoises,
and lemurs everywhere.
everywhere. Well, no, they're enclosed. They're in enclosures, but they're part of Richard Branson's kind of environmental effort, saving some of these animals and they're endangered elsewhere. Yeah, I mean, and then the stars were awesome. I brought a few telescopes, so we spent some time looking at planets.
Is there a good night sky down there? Because I was at a destination wedding last year in Anguilla, but the sky was actually pretty bad. And the
sky is not.
It's actually one of like the most light polluted islands. So
it definitely wasn't light polluted, but so I mean, Necker Island is. It has only Richard Branson's stuff on it, and so it's dark. But it's not the best atmosphere. The atmosphere is a little moist. It's windy, and so you don't get the. You wouldn't do professional astronomy there, but it was certainly dark enough to.
Yeah, I mean, just the first time I ever saw the Milky
Way. All right, enough, Richard Branson. I want to get back to science. Pat Gilmore says, I'm saying that if things are always getting more disordered, we had to start with a lot of order. Why didn't we start with little or no order and therefore get nothing? Matt, this is the follow-up to.
Yeah. Okay. So. This is referring to the idea that the Big Bang, everything was, sort of concentrated into an infinitesimal space, which, by comparison to now, is a very low entropy state. And so my answer to that is the only answer I have is that. Probably in most places, things are disordered most of the time, but we are the product of the increase in entropy. So part of the part of the way that entropy increases is through the development of structure, which can then dissipate heat and increase entropy. So as the universe ages and entropy increases and energy finds new and more efficient ways to spread out more evenly, the development of structure is a natural part of that. And the one video that we look at that is called The Physics of Life. So if you look at The Physics of Life, we talk about that. So the idea is that structure necessarily forms during the evolution of low entropy to high entropy. And so we are things of structure. We necessarily find ourselves in the middle of this process, in this evolution from low entropy to high entropy. So this is really invoking the anthropic principle that we must be in a part of the universe or the multiverse where we can exist. And parts of that greater universe that started in a high entropy state would never have formed things like us. But presumably such places are out there.
And you can see that the early universe is super ordered because it's really smooth. You can see that in the WMAP data, right? So early universe stuff is this really smooth set of basically electron gas or plasma or whatever, and the disorder grows from that because of quantum fluctuations and so on. So to clarify, yeah, the early universe was really ordered, I think.
But it's an open question as to how it got there.
Right.
It's that is not known, and so that I can't answer. Some people suggest that it randomly fluctuated to that extremely high ordered state over, effectively infinite time, but that's speculative. Ask the big question.
Oh, go ahead.
No, go ahead.
Oh, are you familiar at all with NASA's gateway plan for a lunar outpost?
Oh, I mean, a little bit. Maybe not enough. That's a good question, though.
Well, there is a question that says, do you think the plan is the right way forward for human space exploration? Human space, like,
okay.
Would that be a priority, creating some type of lunar outpost as opposed to something else?
Yeah, I think it's crazy not to use the moon more than we do. It's such a gift. It's a rarity for planets like the Earth to have a moon this size, at least it seems so, and so it's much easier to launch from the moon due to the moon's much lower gravity well. So, yeah, I mean, what exactly is the best way to use the moon? I'm not entirely sure. You still have to get stuff to the moon, but in the long term, it seems like you could do a lot of construction on the moon. Okay, it might be easier doing it there than in space, and you could get raw materials to the moon from, say, the asteroid belt, this sort of thing. Anything you can do to avoid having to drag stuff out of Earth's gravity well is good. So we definitely should be using it, whether it's the clear next step. I mean, we can go to Mars without having a base on the moon, but I think for a kind of an interplanetary humanity, it's an obvious resource to make use of.
Matt, Nicholas Alejandro Santa gives a little clarity of to the prior question. What do you think about the experiment of spontaneous time reversal in quantum computers made by Russians recently? That's could possibly break a second law of thermodynamics. That's what they were referring to in the prior question.
Oh, yeah.
Did you read about that?
That kept being thrown at me, and I kept opening the link in another tab and intending to go back and read it.
Graham, did you check that out at all?
No, I'm similarly afflicted as Matt, and
I saw it.
Yeah, I know that it happened, and I know that I'm pretty sure that this is going to be another case where Sean Carroll comes out and says, "Hey guys, this isn't the arrow of time; it's different." So I think that am doubtful that it's true time reversal in the sense that people think in the arrow of time. It's more likely a parody time reversal type thing, that similar to what we covered in a couple of episodes.
Right.
I don't know for sure because I haven't actually read it, so.
That's part of the reason I didn't jump on it immediately, because these damn pop sci headlines are always the most sensationalist that you can imagine, and so I'm scanning for it now to see if I can quickly have a look. But it's like time crystals. Time crystals are not the things that you use to make a TARDIS. They're nowhere near as interesting.
Someone needs help with their undergraduate research project on pulsar timing arrays. Do you have any experience with Markov chain Monte Carlo?
Some.
Enough to tell everybody else kind of generally what it might be and how it might relate to pulsar timing arrays, Matt? Putting you on this motherfucker right now?
I feel like wait, who is this?
This is Mr. Das District. DACEDRIC.
I mean, Markov chain Monte Carlos are just a kind of a way to do fitting of simulations, but they're used everywhere in certainly in astrophysics. So the specific relation to pulsar timing arrays, I'm sure there are many different relations, but for those of you who don't know, a pulsar timing array is a galaxy-sized gravitational wave observatory. The idea is you have the disk of the Milky Way galaxies is speckled with these pulsars, which are these collapsed dead cores of stars spinning so rapidly that neutron stars that we see their jets sweep past us, and the sweeping of the jet provides this incredibly accurate clock, and so we essentially have these timers that we can look at started across the disk of the Milky Way, and when a very, very large gravitational wave passes through the Milky Way, much larger than we see with LIGO, you can see little differences. At least in principle, you can see tiny differences in the way these clocks, the ticking of these pulsars change. And so far, I believe nothing has been seen, but they should be able to detect a particular class of gigantic gravitational wave, very long wavelength. So I assume the Markov chain Monte Carlo is trying to find the gravitational wave signatures that fit the pulsar timing signal scene, but I don't really know. It's extremely cool stuff.
This is an interesting question from 6CEF. Why are we surprised with the uniformity of natural phenomena in different parts of the universe? Like, we'd expect water to boil at 100 degrees on opposite sides of the universe.
Yeah. You got an answer for this one, Graham?
Well, I would say that's not necessarily true, because it depends on the atmospheric pressure. So the boiling point of water will be different if you're at the top of a tall mountain and so on. So in terms of generally uniform things, if you mean things like the laws of physics or something like that we should get the same answer for some basic experiment that we perform in different parts of the universe, it's just kind of an assumption in some sense. That's when you kind of do science, you're assuming that you can do a bunch of experiments that lead you towards an underlying set of laws that is the same everywhere. And if you find a difference, then we sort of say, well, that's a local difference, and there's a deeper set of laws, and that's why we keep looking for deeper theories when we have these mismatches. So you have gravity behaves differently on a large scale to matter on a small scale for quantum mechanics, and there's this sort of gap. So you say, well, there should be something deeper, and you have things like string theory that come up to that. So yeah, I mean, if you get a different answer, then I'd say there's a deeper theory somewhere, if it's something you expect to be the same in those two places. But yeah, it's kind of an assumption or an ansatz for the way we do science.
Matt, you're muted. I muted you because there was some kind of weird animal sound coming through. Didn't know if it was from yours or maybe it was from Graham's because he's in Australia.
It might be. There's yes, exactly. There's a drop bear behind me. No, there's some construction going on, so I apologize.
Oh, I thought it was like an animal. Matt.
No, we build houses using koalas and kangaroos here. So
oh, that makes sense. Yeah. Okay,
so,
Matt.
I just want to add that it is a founding assumption in astronomy and in physics, and we call it in general the Copernican principle, because Copernicus was the first dude to mathematically demonstrate that in fact the Earth probably wasn't the center of the universe, but extending that philosophy, the Copernican principle says that we are not in a special place, and that other parts of the universe are likely to be much like here. So there's that. That's just a philosophy that we hope is true because it makes it possible to think about what's happening out there. That the laws of physics extend beyond the Earth in the same way. But it appears to be true. For example, when we look at the spectra when we break up the light received from, say, different distant stars or distant nebulae, we see the signatures of the familiar elements of the periodic table. Okay, the wavelengths of light produced by electron transitions that we know to be corresponding to these very familiar elements that we see, and they appear to be behaving just as they do on Earth. Although sometimes in much more extreme conditions. So far it appears to be true. We did do one episode that Graham wrote on is the fine structure constant changing, and so there's definitely the possibility that the laws of the universe do change. The constants of nature do change over space, and possibly even over time. But we haven't found what I think of as very convincing evidence that that's the case. If they do change, they don't change very quickly.
The person who asked this question made a clarification as well. They said, he said, why is galaxy formation expected to be different in different parts of the universe? In reference to like inflation. And Graham, you had possibly some thoughts about that. We were chatting about that.
Yeah, so I guess if it's in terms of inflation, then that sort of solves the flatness problem and horizon problem and things. Whereas it's not so much that we expect experiments to give the same result in different parts of the universe. We can do observations and show that things very far over that way look the same as things very far over that way, despite the fact that in principle there hasn't been enough time since the start of the universe for those things to sort of interact. And so it's very hard to argue why you would think that, this kind of requires some sort of mixing. And so this leads you to the idea of inflation, which says, well, they were actually very close together at some point, mixed and became similar, and then were thrust apart faster than the speed of light, actually, in I think all inflation theories. And that aspect explains the observed fact that we see things to be the same in opposite ends of the universe, effectively. So it's not so much that we assume that to be true. It's kind of measured. I guess, is that right, man?
That's right, Graham. I was gratified to see that Mr. De Cedric and Nicholas kind of hashed out some of the Markov chain Monte Carlo stuff without us in the chat. So nice going, guys.
Yeah. My understanding of that is it's a way to sample from a probability distribution when normally that would be really computationally intensive, and that's kind of a stochastic way to do it. I don't know if that helps anyone.
This is a cool question from Strike 497. What are your thoughts on the increased applications of unsupervised machine learning tools being implemented in the near future for building mathematical models of our universe?
Yeah.
Yes.
I mean, I think there's. I'm getting into the game myself, so I'm all for it. I think there are dangers because dangers if they're not used well. But those same dangers exist, I think, in any type of mathematical analysis or computational analysis. The problem with machine learning, supervised or unsupervised, is that it's a black box, and it's very hard to understand how the algorithm reached the prediction that it did. And so that makes, well, so that's challenging. But that said, particularly in astrophysics, we can train our machine learning algorithms much more thoroughly than is possible in many sciences, because a lot of astrophysics really lends itself to simulation. And so we can simulate the hell out of the universe and train our algorithms on those simulations. We can simulate all parameter space that we think is interesting. And so we're not, if you're in any science that involves, say, people and, information about people, say any type of medicine, then your training data sets are severely limited. And so it's really hard to understand the full parameter space. And that makes it incredibly difficult to understand, the uncertainties and, whether your machine learning prediction is some kind of, strange little pathological local minimum in the parameter space. But I think we have cause to be more optimistic in astrophysics.
There are applications in quantum chemistry and atomic physics where a black box is actually kind of fine, and people sort of find that. So machine learning has been doing some cool things there in quantum chemistry in particular, where you unfortunately can't do what Matt said, really. If you want to simulate something exactly that has more than sort of 9 electrons, you're pretty buggered. So you have to hack and slash a bit.
Adrian Molyneux says, I've always been curious about what happened before the Big Bang. I think everyone else is as well, but is there any
not interested.
Speculation, insight, ideas?
There are ideas, but there's nothing close to an accepted anything. I mean, the standard thing people say is that time started at the Big Bang, so that there was nothing before it. And that may be true, but it may also not be true. All we know is that at the instant of the Big Bang, the universe was in a hot, dense state. That's what we got. That's what the observations show. But the original notion was that time started then. But there are ideas like eternal inflation, which has the Big Bang as just the moment that our little part of the universe stopped inflating and became a regularly expanding universe. There's a million different. Maybe we should do an episode on all of the different ideas of what came before the Big Bang. But it sounds more like a long series.
That would be a fascinating thing to touch on, even in one episode, as a kind of survey. But Matt, you don't do anything by halves, so you'd probably want to do like 4 episodes on it. No, it's a good curse. What else is going on? Catching up. There's a lot of good stuff that's been written just over the last few minutes. Graham, Matt, have you guys seen anything you want to jump into as I look?
Brian says I should grab a new beer. That was my last beer. So
that is a sad state of affairs.
Guys,
the stream's over. Everyone go home.
Oh, here's kind of a fun one. What applications would a quantum computer be useful for in cosmology?
Huh.
That's a good one.
That is
tricky.
Do you need to factorize what's more about numbers? Or other problems? That's about all you can do, right?
Where are we limited with computational power right now in cosmology?
I mean, So the biggest challenges in cosmology are so-called n-body simulations, trying to simulate huge numbers of particles, and so simulating little mini universes as they expand and interact gravitationally to see, to see what type of universes you can end up with. See galaxies form and structure form and all of that stuff, so you can kind of test out ideas about dark matter and dark energy and all this stuff. But these are time sequenced simulations, and so I don't think you gain anything from the main benefit of quantum computers, which is running parallel calculations. Does that sound right, Graham?
Well, in the n-body stuff, you make use of parallelization quite a lot, I think. But I think the main drawback for quantum computers is that it's not just like a faster classical computer. You can't do all the same kinds of calculations, at least not yet. There are a set of algorithms, like Shor's algorithm is maybe the most famous one, and I think PBS Infinite did a cool video or two on that. To basically mean there are certain types of mathematical problems that, at least in the near future, quantum computers are going to be really good at. For example, factorizing large numbers into their prime components and things like that. So I guess I don't know if there's anything currently that is obvious that there's an algorithm that would solve a particular part of what Matt described as the n-body simulation. Maybe, but it would have to be, it's sort of tailored. It's not obvious that such a thing would exist. It's not just a bigger, faster computer that can do all the same things, unfortunately. At least not yet.
Yeah. In general, I haven't heard a lot of talk about people being excited about using quantum computing in astrophysics, but it may exist. It may be a thing.
Dustin Edgman has a cool question that Zach Haleman kind of seconded. It says, basic physics here, refraction. What the fuck? Electromagnetic wave travels in a straight line and then starts vibrating with electrons, which causes change of direction and slowing down. That one doesn't make sense to me. And Zach says, I'd also like a satisfying answer to how refraction works on a quantum level. A satisfying answer that,
That costs extra.
Yeah.
So you want to know how rainbows are made?
Who doesn't?
Yeah, I learned this as a classical description in which you have classical wave fronts, and so my physics understanding of it is very classical, which is clearly not adequate. Well, no, maybe it is adequate. Okay, so I can understand why refraction works for waves in general, and it's it's simply a matter of the differential speeds between the two media. Okay, and so if you have a wave front coming into a medium, the part of the wave front that ends up slower that hits the medium first. Okay, maybe I can pretend let me see if I can do this. So the wave comes in. I know this isn't really answering the question, but the wave comes in, and the part that hits the medium first slows down. Okay, and so you end up with this kind of changing angle as it comes through. But that's for a wavefront, and you can look at videos on YouTube of water waves doing that as they pass across a sandbank. Part of it slows down, and so you get the whole wave changing its direction. But when you get to if you want to relate that to individual photons, then as soon as you talk about photons, you're talking about the quantum scattering of particles against particles, and infinite sets of Feynman diagrams, and somehow that leads to these emergent classical relationships. But they still really confuse me. Even how the simple Coulomb force of say two electrons repelling each other, or a proton and an electron attracting each other, can be explained in terms of the exchange of virtual photons. Like you lose intuition there. So the short answer is no. I can't explain that in a satisfying way. But can you do any better, Graham?
Yeah, I guess I wasn't going to go all the way down to the quantum field theory, but I think you can make arguments based on what you just said, which is particle scattering. So if you have photons coming in, well, I guess the first thing is that you can't have, I don't think you can have the deflection of photons in the same way that you can with other things in terms of sort of billiard balls. So if you fire an electron at something that has other electrons, you can imagine a sort of smoothly, continuously deforming path as the repulsion happens. Whereas with a photon, it actually doesn't feel the electromagnetic field. Photons don't actually interact with other photons in that way. So you necessarily have absorption and re-emission. So you have the photon gets absorbed and then gets kicked out at a different angle. And because maths, the angle that it comes out at is influenced by the atom in this other collection of atoms, which is the medium. And so this will determine what scattering angles you can get. So if you have a bunch of photons come in, they will get absorbed and re-emitted into the medium and bounce around. And this is why you have things like the optical or the speed of light being different in different things. So the speed of light, which superficially would seem to conflict with special relativity, because we say that it doesn't matter where you are or what you're in, the speed of light should be constant. And so the reason that light slows down in these other things is because it's bouncing around like in a pinball machine and being absorbed and re-emitted all of the time. And that gives you an effective speed in the medium. And so I think basically the scattering angles are constrained by the medium that you're in, and that gives you the angles that will give you refraction as stuff comes in an event. For an ensemble of photons to get the classical solution, not too sure, but I think it's something like that.
Well, I'm satisfied.
Good.
Oh, good. You owe me the extra fee then. I don't know about anyone else.
Arbitrary constant says, what is black hole hypercomputation?
I haven't heard of that. What is black hole hypercomputation?
Arbitrary constant is like, I just made it up. Arbitrary constant. You have any more info on that you can pop into the chat? Black hole hypercomputation.
Is this related to somehow using black holes as computers because of their very high entropy or something? I vaguely remember that being a thing that was being bounced around.
While arbitrary constant works on that, Nice Man Dan, which is a really excellent screen name, by the way. Is it possible dark energy is evidence of many worlds theory, multiple universes close to ours, created from quantum possibilities, expanding space at an accelerating rate?
I don't think we can say no.
It is one of those.
I feel like I've heard of that sort of thing before, but I don't know how seriously it's taken.
I feel like in each case you would need dark energy for the sort of sub-universe to expand, to give rise to expansion. I don't know that you can explain the dark energy without having something that is causing empty space to expand, which is itself dark energy, even if the intermediate step is you're making more universes or something like that. I think. I don't know.
Side note question with the many worlds: what quantum interpretation camp are you in?
Ooh. Maybe none of the above. I don't know.
Oh, really interesting.
Satisfying. I mean, I can say not Copenhagen, and probably not Pilot Wave, the Brøybohm. Copenhagen is just really too inconsistent, and Pilot Wave to me is just really reaching a little bit too hard to maintain physicality that that I don't think we have any business trying to maintain anymore. So I think Everett's Many Worlds is closer, but I'm not willing to say that I believe it.
Yeah, I feel like I know like Sean Carroll is all about it. I don't know if it's like a little more in vogue now.
It is more in vogue, I think, but with good reason. I think it's a coherent story. I don't think Copenhagen is particularly coherent. What about you, Graham?
Yeah, but similar story. I think I've sort of been forced towards Many Worlds because the other stuff is a bit crap. So, and I'm also in the Sean Carroll bandwagon. I think that was probably the first general explanation that he gave, especially in terms of how you can naturally get things like entanglement and so on, or how that's the fundamental sort of component that gives you these many worlds. Yeah, I found that sort of quite satisfying, I think, actually.
Mm-hmm.
I don't know beyond those three if there are any other main contenders. I don't think so.
Stefan Matches.
There are, but...
Oh, go ahead, Matt. I'm sorry.
I'm already satisfied with the answer. Very satisfied.
Okay.
Danby, I'm glad you feel satisfied.
Totally satisfied.
Stefan says, I have had a question for a long time. Could dark mass be something like interaction with gravitational quantum field, but in a different way? What is the different way? But you see that question, Matt? Could dark mass be something like interaction with gravitational quantum fields?
Yeah, I mean there are ideas around this. The quantum inertia is kind of exactly that, suggesting that not just gravity, but God, how does it go again? But just like the very sort of concept of acceleration is quantized, and so on very large scales, my recollection is that if you consider, I think the idea is that you can consider inertia or acceleration or something in the same way that you consider the waves of a quantum field, which are bounded by the edges of the universe. And so if you talk about large enough scales, then you get these quantized limits in what accelerations are possible. It's like almost like acceleration is pixelated in a way, and I might be totally screwing this up, but do the calculations, and supposedly that explains dark matter, probably dark energy too. It's a British physicist who's all about quantized inertia. I don't believe it. I think it's a bit wacky. But people often ask us to do an episode on it. Haven't decided if we should do that yet.
There's a follow-up from Arbitrary Constant on the black hole hyper computation thing. There's something about how an unlimited number of classical computing steps can be completed in a finite amount of time.
Well, that would be cool.
Seems pretty crazy pants to me.
Yeah, but it has to be the right type of step. They have to be parallel steps, so they can't be steps that rely on the previous step, which does limit the use.
On the Matt, if you don't think we should not maintain physicality, what do you think we should think when we think about the quantum level?
We should just be willing to abandon physicality. I think it's pretty clear to me, at least, that once we're talking about the quantum realm, our sense of physicality is relatively meaningless. So, at this point, we're getting to the biggest questions of all, like how do we think about the fundamental elementary components of existence? And I think I think most people believe it's naive to imagine that there is a smallest possible thing, and that thing is a thing, and that once we find that elementary particle, the most elementary particle, perhaps we have already, then we've reduced the universe to its most irreducible state, and we're done. I think it's pretty clear that, it makes sense to me that the most true underlying description of reality is not going to be one that satisfies human intuition in the way we would like it to. It's going to be abstract, probably mathematical, and probably not physical. That's my guess. Graham?
Yeah, well, I have to duck out some of the question, but I would say that the fact that you have quantum mechanics and things like relativity show that our squishy, like savannah ape brain is not really good at dealing with the stuff without some sort of mathematics and things like that, and inventing fancy machines to get through our own biases and things like that. We live on a classical scale, and there's no reason to expect the universe to play nice so that we can understand it. And it could be turtles all the way down, right? Maybe we never reach the bottom. That would be really unsatisfying, but at least it would keep physicists employed for a while. So we'll see. But yeah, if the notion of physicality is not, if by that you mean that it's kind of viscerally satisfying to us in terms of intuition, then there's no reason to necessarily save that at the expense of accuracy in describing experimental outcomes.
Keeps me awake at night, though.
Coffee keeps me awake at night, but that too.
Bill Watson says, Lawrence Krauss insists that the universe came from nothing. What do you think of the idea that the universe came from pure potentiality? The question is, what then is pure potentiality?
Yeah. So I don't know what pure potentiality is, I guess.
It sounds a bit Deepak Chopra, potentially.
Yeah, so came from nothing. Even that, I don't know what that means. Go on.
I was just going to say, I think at some point, I listened to that audiobook, and it ends up being a cosmology textbook that delays things up until the end, and then it's kind of, you can get something from nothing in that sort of quantum sense of vacuum energy and all that sort of stuff. But I don't. That opens the possibility that all the stuff in the universe sort of spontaneously came out of nothing because of a very low probability event happening. But I still think that doesn't necessarily answer the sort of pre-Big Bang question, because you still have conservation of energy and other things like that. So I think I'd probably default to what was said before about either the Big Bang kind of happened and the notion of pre-Big Bang doesn't make sense because time didn't exist, and that's really unsatisfying, or you have something like cyclic cosmology or eternal inflation and things like that. I don't know if I agree with the idea that you can use the something from nothing kind of argument for the whole universe globally. You can sort of wrangle it locally for some things, I think, but I'm definitely not a cosmologist. Sean Carroll probably has something cool on this somewhere.
My issue with this whole thing is that you still need the rules. You need to start with the rules.
Exactly, and that's part of the universe, right?
You need to have nothing that has rules, right, before you can.
And then you have something. So you.
Yeah. So
yeah, even if you have empty space, that's stuff, right? And if you have empty space, that's going to give rise to other things according to the laws of physics. Then is that really nothing? I don't know.
There's just a copy of Sakurai quantum mechanics floating out there in the void.
Yes, it's all Boltzmann brains or something, presumably. That's why the being our universe being a simulation helps a bit, because it's not really our fault. It's just someone else did it. It passes the buck at least slightly.
Right. There are other worldviews that also pass the buck that we're also not satisfied with.
Yeah, I think they all do. It have to some degree.
David Gerke says, I like Max Tegmark's idea that the universe is a static mathematical object, and it seems like it changes to us because we're inside it. Mathematical objects aren't created.
I have to say I like that idea too. So Max Tegmark has the idea that all things that can be described mathematically essentially exist.
That's interesting.
Yeah.
Does that apply to things like numbers and so on?
Well, they don't exist. I mean, you don't have digits floating out in space, but my sense is the idea that if it's a coherent mathematical structure, then that in itself is enough to grant it existence. But it's pretty loopy. But
yeah,
I think we kind of need to be pretty loopy.
Yeah, some of this is going to be axiomatic at some point. You either define physics as the thing that describes the universe, or you say the universe is stuff described by physics. So.
Right.
Australia's so loud.
Yeah, sorry about that.
There's a really good Sean Carroll podcast about this very subject. For anybody who wants to hurt their brain trying to follow along for about an hour.
I'm already caught up with all his episodes.
Say what?
I'm already caught up with his episodes. It's actually a good podcast overall.
Pretty good. I just hate the ones that aren't about astrophysics. I'm like,
yeah, I agree. Even though like you wanted to branch out.
Yeah, like don't branch out. Don't branch out. Hey, so big news, guys. Space Time is developing a podcast that will give us the opportunity to do some longer form stuff and longer conversations in a little more conversational fashion. And that's really exciting for us to be able to, talk for an hour. So that's coming up over the next couple of months. And
like guests and stuff, or like what's the?
We're not sure yet, to be honest. It's kind of, but definitely will be guests. Definitely will be other scientists. The focus will be high level, rigorous conversation, same as the YouTube channel. But we're still kind of figuring out the right format for it. So all that said, hit me up over email if you have ideas or if there's things that you would like to see in a podcast, things that you'd like to hear Matt talk about for a long time or Graham talk about for a long time. Ideas for the kind of conversations that you think would be cool in a Spacetime podcast, because we're developing it right now. So everybody on this Hangout has got my email.
Guest suggestion. He was just on Sean Carroll's too. David Albert. He's really fascinating to listen to, because it's like he's a philosopher that's actually a physicist also. So it's like good stuff.
Okay.
Wade says, Matt looks like this is the first time he's hearing of this. It's not the first time he's hearing.
That's just how he looks.
I have to do a podcast now.
Yeah, we're doing a podcast.
This is why I do this Hangout, so that I can find out what's going on with Spacetime.
Oh, we have big news. Matt is being let go from.
Wait, so you're saying that there's a position opening up? Is that?
Okay. Okay, yeah. I'm glad that people are excited about this podcast.
A few months sounds long, though. Hurry it up.
I know, right? It's just a podcast, right? Come on. Now we'll get our stuff together and get it going. Okay.
Oh, one last on what would be like the frequency? You think like a weekly, monthly?
We want to do weekly, if we can swing it. It's about the format, really. You know, if we choose a format that is producible and that doesn't that's not a crazy heavy lift, you know, because Matt clearly has limited time, and we got to make sure that it's.
Why? Because he's drinking all the time?
I mean, yeah. No, it's because he has a full-time teaching job, and he does space time, and he has a personal life.
No.
That's not allowed.
I'm chilling with Richard Branson on his island.
Right, he's got to go to Necker Island every weekend.
According to David, I'm on Reddit the whole time, looking at David Goic. Matt looks like I do in meetings, reading Reddit on the side while people talk. No, I'm actually reading your comments to try to find good questions.
He's looking at cat pictures. Yeah, Daryl Descharmes says, yeah, it's an interesting difference because it's audio versus visual. And it really is. Audio is a totally different medium, and it takes a different kind of thinking about the format in order to make it interesting, because there's no pretty pictures. But because it's audio, it's cheaper to produce, and so we can go longer. You know, we don't have as much time pressure. And so, yeah, it's like a whole new, it's literally a whole new world. We're going to have fun with it.
I have an important question about that, which is, oh, sorry.
But that doesn't mean that you guys have to stop.
I was going to ask if the most important thing had been settled yet, which is like the intro music for it.
Right. Right.
That's why it's going to take a couple of months.
I'm thinking like the X-Files synthesizer theme.
You got to hire the orchestra and everything.
Well, I mean, obviously.
It's going to be live music each time from a different
We're obviously going to have the most expensive solution. Okay, Matt, any parting words before we wrap up?
Just that the holographic principle is nearly here. Finally. I've been putting it off for so long, but we
oh yeah
we split it in half just one more time. I was going to record it. We were going to record it yesterday, but over the weekend I decided, you know what, I'm going to split this one more time. And I really love the thing that we recorded yesterday.
Does that mean that it's now a 4-part?
Well, it's now. I mean, it's now.
It's actually like a new channel.
Yeah, it's a new. It's now multiple playlists.
Yeah, there's a joke in there somewhere, right?
But we did one yesterday called, well, working title is "The Boundary of an Infinite Universe," and how you can define a boundary of an infinite universe. And it involves a lot of MC Escher, but it's and also some, I think, pretty cool math. But it is, as far as I can tell, the last thing we need before we do full ADS CFT correspondence and the holographic principle. Phew.
Beautiful.
After that, I have no idea where space-time is going to go.
Yeah, Andrew was wondering that the other day too. He was like, "What's next?"
Well, I guess we'll all find out
on the next episode of Space Time. Thank you, everybody, for the awesome chat, for your amazing questions, and for joining us from all over the world. It's so incredible to be a part of this community, and that it's become a global thing. We're so grateful.
Ditto.
Yeah, what he said.
What he said.
Not what he said.
Damn
Bye, everyone.
Combo.
See you later.
Okay. Thanks so much, guys. See you next time. Next month. Definitely next month.
Definitely next month. You guys are amazing. Thank you so much for the support over these years. We're gonna keep doing great stuff for you. I'm going to stop the broadcast in 3, 2, 1.